Okay, so here you have original thing. Yeah, so you have original thing. And then you have added thing, which is nice because we also have the plus button, not button, but symbol. And then we also have that. Then over here we have our, I think that's the trick right there. Okay, so it says how many kilograms of water must be added to 12 kilograms of salt? Well, what, so water, yeah, so that's gonna be your amount of added thing, would be your X right there. And your original thing, well, what are we adding the water to? So where's the 12 go? And then where does the percent of salt solution go? Yeah, so that's the percent, and that 30 should be really a 0.30. And then you have to know, like, what's the percent? Okay, so when you see this percent right here, if you think about a container, like let's think of a fishbowl. Here's what like a 2% solution looks like. A 2% solution means that you have, I like to think of it as 2% rocks over everything. And that everything actually is the 2% rocks are actually included in there. So if I were to go, I'm going to say, all right, I have a little scale right here, and I'm going to get two rocks. Those are my 2 rocks. Like 2 rocks. And then I'm going to add my 2 rocks to my 98 marbles. I'm going to end up with how many combos, like all together, rocks plus marbles will I get? I'm going to get 100 in the mix. So there's 100, yeah, there's 100 rocks. There's 98 marbles and 2 rocks. So you can clearly see the 2 rocks over here, which means, so there's 98 marbles, 2 rocks. You can clearly see the 2 rocks here and the 98 marbles. So if I want to figure out my percent rocks, then it's going to be 2 rocks out of 100 everything, because that's what's in the everything right there. And what percent is that? 2%, right? I could actually do marble percentage if I wanted to. What percent marbles do I have? So yeah, 98% rocks, or 98% marbles, or 2% rocks. What's kind of confusing a little bit about like things inside of water is that you really have 2% of something, and then, or like 2 like kilograms of something, and then 98 kilograms of water rock. If you have a 2% solution, there's going to be, and I'll just make this a 2. Like, instead of thinking of the water as liquid, think of it as the water as just like marbles. If you go like that, and you have, I'll just do it like red. There's my 2. I was doing it again. There's my 2 kilograms. I think I just made up the 2 thing. But there's my 2, like let's just say kilograms of salt. That means that I have to have 98. For every 2 salts, I have to have 98 water molecules. Right. So then when you add, so now I have these two red dots, and then it's going to be out of how many total dots to get a 2% solution. So I would have 2 red dots out of how many total dots to get, which means you have 98 blue dots. So you have 98 water molecules, but you can think of the water molecules as marbles. But that's what gives you a 2% solution. So it's including, the bottom number includes the rocks that you're putting in the water and the water itself. So when you have a 30% salt solution, that means you have, for every 30 kilograms of salt, that's going to be over 30 kilograms of salt plus 70 kilograms of water. That's how you get, and this is your 100. You see, so a 30%, so the number on the bottom includes also the salt plus the water. So that percentage means like how much there's salt, how much of the percent salt there is in this solution here. So it says how many kilograms of water must be added to 12 kilograms. So you have a 12 kilograms of a 30% solution. So if you want to make a 20% solution, if you want to make it a less of a percentage, you need to increase the water dots. You see, if I start increasing my water here, that percent 2 is going to go down. Right, because now I'm adding in more water. So that's how you're going to go all the way down to 20%. So then over here, the tricky part about this problem, which doesn't always apply to all problems, but is when you add water, is you say, all right, they want to know how much water you're going to add. That's your X. And then this one here is what's the percentage of rocks inside of water? What's the percentage of rocks inside of pure water? 0%. But if it was like trail mix or something, it would be you would actually have a number here. So if you wanted to lower the percentage of, let's say you had 12 kilograms like of trail mix, and that was like a 30% solution, and well, actually it'd be like more like 12% of like nuts. It's like the whole thing is trail mix, so like nuts. And then there's like, so if it's 30% nuts, you have to input more raisin if you want to lower the nut percentage. You have to add more raisins, but when you add more raisins, you're gonna like, you could have like a container that has like a raisin percentage in it, and that raisin percentage would go in here. Yeah, so this is like some sort of, this is like one container. Did you say it's a container method? Because that makes sense to me. So this is like one container. Oh, okay. So look, okay, so watch. Like you have like if it was like a trail mix thing, you could have like nuts and raisin. Oh, nuts, and then raisins. I'll just do as they are. Raisins. 1, 2, 3, 4, 5, 6, 7. What's the percent of nuts? Like this right here is a what percent nut container? Well, what? It's 3 over total. Well, I don't have 100 there. You have to, so 3 over total, which is 10. So that means that's a 30% nut solution. But if it was, what's the percentage of raisins? What percent raisin solution would it be? It wouldn't be a 10% raisin solution. But say you want your little trail mix package. You don't want it to be 30% nuts. Oh no. You want to be let's say 20% nuts. So if you want to be 20% nuts, do you have to add more raisins, or do you have to add more nuts, or what do you have to do? Except the only problem is that this container over here has nuts and raisins, but the nuts and raisins are, let's say, 50-50. So you have nuts, and raisins. Oops, supposed to be R. 1, 2, 3, 4, 5. All right, so what's this percentage in this guy? What's the percentage of nuts in this solution, the second one? There's 10 blacks and there's 5 blacks and 5 reds. There's 5 nuts. So this is a 50% nut solution. Okay, so now that I just realized that this is the stupidest example ever. So I would have to go, like, let's say the problem is not to lower, I can't lower the nut. If I mix the two, am I going to lower the nut percentage or raise it? I'm going to raise it. So I made originally a bad problem. So let's say I want to make a 40% nut solution. So you mix these together and then combined, what's going to be my percentage that I'm looking for? If I want a 40% nut solution, what's going to be my combined? You know, like if I want a 40% nut solution, this is my combined container. What's the percent of nuts in my 40% nut solution? Yeah, 40%. So that's the number that goes here. So when you combine these, you're going to raise this percentage. By combining these, you're going to raise that percentage. All right. So, and what these problems are going to do is they're going to give you, well, actually, a better way to do it would be this. They're going to give you, like, I'll just do it over here. No, I'll do it here. So you have, like, you'll know, like, your percent. So, like, the percent here will be 30%. The percent here will be 50%. But then combined is not a matter of adding them. It's what you want. It's what you want. You want a 40%. Yeah, if you want to find that percent. And then here, they're going to say, all right, well, let's say they're going to tell you that you want like whatever, like 80 kilograms. So say you want like 80 kilograms. Well, now you can, as long as, what's going to happen is they're going to give you everything but one. They'll give you that, and you solve for that. So yeah, so just know that you're going to like, all you're going to do is I think this will probably, if you understand this little setup will work, because what he's going to do, he's going to give you 2 of these. And then you're going to use your algebra to find the missing one. So you might get that one. You might have to find that x over there. Or maybe you'll have to find that x, and you'll get that one, like that. Okay? Okay, so yeah, let's go back to the original. Oh, and then you multiply down. Wait, let me see. Yeah, you do. You do that times that plus that times that. Yeah, you do multiply down. Okay, so yeah, so then you add across, but remember, you don't add your percentages. So all you're adding across is the top. You're just adding that. So that plus that equals that, but that plus that is not that. So it's almost like you can go like, but then the top one is just left out. It's almost like you can make like a cooler looking grid thing actually. Like it should have like one, I should go across the top like that, but then on the bottom, it's like, because the tops can talk to each other. So it's gonna be like, it's gonna be 12 plus, well no, but you have to actually multiply them. Oh, never mind. Okay, you just have to know that. All right, so multiply down. 12 times 0.3. Now add. Plus x times 0. Equals. Oh, and then what do we need over here? Exactly. This is going to be 12 plus x. And then it's going to be 0.20 times 12 plus x. All right, so then you have 12 times 0.30 is 3.6 plus 0 equals 0.20 times 12 is 2.4 plus 0.20x. Okay, now what? All right, so 3.6 equals 2.4 plus 0.20. So 3.6 minus 2.4 is 1.2. 1.2 is equal to 0.20 x. The decimal? No. But you could do, there's other stuff you can do. I wouldn't. All you could do is, as long as you know what you're doing, you have to multiply everything by 100. So now what do you do? All right, so divide by 0.2. Boom, divide by 0.2. And then how do you set this up? How do you do this, like set up this division problem? So 1.2, and then you have your 0.20 here. Now what do you do? All right, on the left or the right? On the outside or inside? So 20 happened there, and then you went do-do-do, you went bloop and bloop. 1200, you sure about that? 120, all right. You want a 0 there? I think it goes evenly too. Okay, so put the 6 here. Bing. And then 20 times 6 is 120. And oh, technically the 6 doesn't go there, but who cares? The 6 goes actually here because 6 can't go because 20 can't go into 12. So 20 goes into 120, so the 6 goes here. And then there's no decimal, so it's 6. So that means what goes right here. They want to know like how much. What are they asking for? Yeah, how much kilograms of water must be added? 6. Is that what your teacher got? Oh, I can look it up. Hold on. 6 kilograms of H2O because I have the answer book.